Tuesday, 8 p.m.
Morning, guys.
Morning, sir.
Yeah, so I'm going to start this. I'm just waiting for one guy to mute. I'm gonna start on the UPSs. So a lot of guys can't join us, but they are requesting videos and stuff. As much as I wanted everyone to be listening or to be seeing me, it's okay too. So for UPS is one of the most important components among the power components of a data center, right? Like we discussed yesterday, and the example I gave about water, kuti mvura inobva kulake Chiwero youya ku-residential area. Painouya ku-residential area inosvika ichipinda mu-processing plant. Mu-processing plant muya panotanga kwainosvika ichitanga kusefewa handiti, ichibvisa marara, all those matombo and stuff, ndo anonzi mafilters iwayo ari part of the UPS. Ndochekutanga ichi chimafilters handiti. So tinawo mafilters muma-UPS as well, kwekutanga ikoko anobvisa marara ese, sorry, mashizha, all of those things handiti. Then we go into the process where we put chemicals into the water handiti. That's the rectification process. I'm explaining now the second part, which is the rectification process.
Don't jump on the bed, jump on the floor.
Where we convert
This will be very hot.
AC,
When you open pulse,
AC voltage into DC voltage.
It's
Right.
going to be very hot. About 25 degrees.
Where we convert AC voltage into DC voltage, right? That's the same process, but no add chemicals mumvura kuti start the purification process, right? And but no add chemicals. That's when we keep that water, some of the water in the tanks, ichimirira kuti izo purify yakubvisiwa those chemicals again, and it into drinkable water yozoregerwa ichipinda muharare. That's the process. Saka isusu paprocess paya patinoisa matanks ekuchengeta mvura kuti in case we have a problem up there upstream for 24 hours probably. Most matanks mazhinji anochengeta for up to 24 hours. 24 hours kana kuri kumatanks. Ma-UPS wo zvinodependa nesize ye-UPS kana size ye-load yedu. Mabattery anozokura sei. So exactly the same process. So we can only keep mvura iyoyo yakaiswa ma-chemicals already, because that's the fastest way we can back up community yedu kuti isashaya mvura for the duration. So that's the UPS I'm explaining to you. And patinotora mvura yaya takuiconverta back into drinkable water, that's the rectifier. So in layman's language, that's the easiest way to explain a UPS. And you're gonna hear a word double conversion a lot. So they'll ask you about that. Can you explain what is double conversion? So I've just explained to you double conversion. They could mvura, yeah, inomwika, but inogona kunzisa mudumbu. Yochinjwa into undrinkable water, which is DC voltage. DC voltage is useless to us. We can't, nothing in our equipment cannot take DC voltage to blow up most of the equipment, right? We need to convert it back to AC. So they convert an inverter, and now our equipment can take that. Same as us, chemicals. So the only way we can keep that water is via, we can keep voltage through DC voltage, right? That's the only backup we can have. Saka pa backup apa tine ma options atinawo akafana mabattery for my small stuff, indeed, my small UPS. Then it my capacitor bank for my bigger UPSs, probably my 5 MVA. The party options some capacitor bank, of which it can back up only for seconds, like 5 seconds max. You cannot go more than 5 seconds my capacitor bank. But we are talking of really big systems. Saka, that's the double conversion. You're going to hear double conversion a lot, and they'll ask you to explain what is double conversion. So if you an explanation and that just try to remember that and try to write in your own English what it is. And so first process, sieving all the dead, those are called filters. And to end up at next stage, which is to add chemicals into the water, that's the rectifier. And it becomes undrinkable, but storage can be stored. Then from there, we are changing it back to AC voltage, and using an inverter. That's the process here to know it filtration. You could remove all those chemicals again out of the water system. And so yeah, so that's the first part. Then components of a UPS, different types of UPSs first. Tina anonzima online UPSs, though most common one for my data centers. And it was later anonzima offline cannot line interactive. And so shinongoreva zvakangosiyana ndezvekuti inenge ichinzi online inenge every time inenge ichisupport a load all the time via that double conversion and ndakutsanangurira iyoyo. So all the time inenge yakasupport a load, and there's no then offline means only paneta when we get load shedding. It's how best I can explain that offline is my inverter now kumba. Only the inverter only kick in after we lose power. That's an example for offline UPS or line interactive. So yeah. In Zimbabwe, I know everyone have an inverter at home, so they know exactly how it works. So it will be very easy to understand what's an offline UPS. Then we go to naming components of a UPS. Components of a UPS, like we said, there's a rectifier in the UPS. Nowadays, they don't call it a rectifier anymore. They're calling it a booster, right? Depending on the technology of a UPS. So sometimes they call it a booster, but it's one and the same thing. Apparently, it's not really one and the same thing, but booster is just kuti panoya rectifier in a lower voltage and DC voltage, then the booster will step up that DC to DC. It's a DC to DC converter. Your booster, just a DC to DC converter, but to step up our voltage because we need a lot of voltage, around 400 volts. We may have like 20 batteries, for example, in our system, and you should not tip up system. 20 batteries can give us more or less how much? 240 volts, which is not enough. Sorry, there's a lot of noise happening. Okay, I think it's better now. There's a lot of we have 20 batteries in a system, right? But we need also, it can only give us about 240 volts if they are both batteries, right? 240 volts. So I'm trying to explain the booster part. So we need, for it to supply our load, we have our load at 240 volts as well. So you see, we don't have room to play with. But if we have a booster, now what the booster will do is it will boost that voltage and that DC voltage into probably from the 240 that we have to most of them is 360 volts. They start from 360 to 380. That's the range of DC, not DC bus. Indeed. DC bus meaning could anti rectify no converter from AC to DC, right? And the AC, then we have inverter directly connected to our inverter, to our rectifier, which converts DC back into AC, right? And we have batteries also, battery charger or batteries, for example, connected directly in the center of those two. So it will look like, I don't know if my video can see this. I don't know the pen, but I'll try and do it later on, and I'll share with you guys. So, but I'll do it quickly. So that's the DC bus where all the DC components are connected, including battery, right? Yeah, so probably like this. So we have the DC bus means apa patsakaconnectwa dzese apa ndipo apa kune DC voltage, kune DC voltage, apa pane mabattery. So this is the DC bus. So normally in normal terms panenge pane macapacitor pana. Indeed, capacitor benga atambotaura aya, but here anenge ari internal one. They are not for backing up, they are just for helping the DC bus. So macapacitor anenge akaconnectwa pana. Aya ma DC capacitor, so which means anenge ane plus nema negative pana. Indeed. So this is the DC bus. I'm just explaining as simple as I can, because it's a little deeper than that, but this is how it will look like on the DC bus. So inverter, you are connected to DC bus. So you may be asked, what is the DC bus? Inverter, rectifier, whatever. And it's funny, you can come from this side and achieve the same result. You can also come from this side and achieve the same result. So rectifier, the inverter is just the reverse of each other. And it kangotenderedza inverter yako ukaidai so ukaikonecta nekuinput if it was possible for dzatinadziumba wakutowana DC voltage. No explanation yadada kusama. Then components saka tati tinotanga nechi rectifier, and it yeah, if you understand this DC bus, you can say we have a DC bus, then we have our batteries, then we have the inverter. That's it. But we have one more, or at least two more components that you guys need to know most. But this is the general components for any UPS that you're going to see in the world. So I'm going to add one more, which is called the static bypass, right? So static bypass just meaning internal. Whenever you static bypass, it just means internal, and it this one UPS. It's just two thyristors that oppose that face different side. That's why in the summer my diode. It's just two thyristors, and it static bypass. One of the main advantages of this static bypass is characteristics. Actually, and connect directly on the inverter, right? On the output of the inverter, the static bypass. Serve a few fundamentals, and it like one, whenever tighter problem in a UPS, and it static bypass will not take over the load, right? It's going to take over our load for whatever time or until the problem is cleared. If it's a short circuit, big short circuit, then it will protect the UPS from that big short circuit. It will rather blow up itself than letting the client have that dirty power coming in. So that's the one part. And another another purpose is whenever we have a failure in our UPS, instead of the client losing load completely, he is going to get a dirty water. Zvafana kuti tine zvatotaura zvekuchiwero zviya. Pane kuti ma-residents edu are complaining kuti guys, we don't have water for the whole day and stuff because the staff yafa. Tinongogadzira rimwe line rinovafeeda mvura, but totovaudza kuti mvura iyi haina kuchena still. Zviri nani kuti vanhu vawane mvura yekugeza nepita setovaudza kuti no, mvura yedu yakasviba and stuff, but at least munayo mvura yekugeza and do all the other chores. You can't drink it, that's all. And it so pane ma-parameters ainofana kumita that water and it first kuti izobvumira kuti ipinde into our resident and it which are the same like kuma static bypass inofana kumita certain parameters, right? The first and most important one parameter ainofana kumita is the bypass. Sorry, the frequency of a static bypass, and it is always synchronized to the inverter, right? Which means they need to be at the same time or speed, whatever, synchronized, synchronized stuff. They need to be at the same frequency, right? And synchronized the whole time. So you see that in UPSs, you have a very small window. Whenever you have a little bit of dirty power, UPS will cut off the static bypass line out and let you know, hey guys, my power is dirty, I can't accept this load. If anything happens with the UPS, I cannot give this power because it's too dirty, right? Because it's not meeting the parameters. Like saying, so we cannot give it to our residents because one not to risk. Always the other people who's going to take risk of drinking that water. So please don't. I won't allow this water. Can I meter this and the parameters? So the main one is frequency. Frequency Chanda foot in a way could if it's the same frequency, right? That means when the switching happens, there won't be any interruption, right? So this will lead us to other two terms that you're going to hear a lot, which is open transition or closed transition. And those terms you're going to hear them a lot and you're going to be asked to explain them, right? Or who, if it's an American person interviewing you, who that you explain make before break or break before make. It's exactly the same thing. To open transition and close transition. So break before make, it breaks, right? It has to switch off here before it switches on here, because these are become two different supplies, right? By no pinda but double conversion, but even though maybe they are connected to the same line here, but shika panapa output they are totally different supplies, right? It's like you tora motor ubago ange utora motor ubago ukariba ungozi joinitza usnap. That's what will happen. It will explode. But if it is synchronized, the frequency is the same, and sometimes voltage, which is the second parameter, is voltage. But voltage is not really that bad, that critical, unless it goes out to, I think it's about 10%. But for frequency, you cannot go more than 2% on most UPSs. They'll start complaining, especially for IT equipment. And then another parameter, like I mentioned, is the voltage, right? Voltage, I think it's from 10% that they want it to accept. Otherwise, if it goes up to out of the 10% percentage, plus or minus, cut off. So these diodes are just drawn in. These are just thyristors. they are used because of their capability of switching very fast, and faster than our eyes, faster than before any equipment can pick it up. So it's like 100th of a second. That's how fast this thing switch. Right? Because we are switching high voltage here and high current. So that's why this invention was done. So that's the next part. So I've just explained to you the static bypass. So the static bypass is the next important thing, which just is a cover in case anything happens here, or someone, a connector, maybe something like a vacuum cleaner, which is a short circuit. Instead of blowing up here, all smart UPSs, they'll transfer and try and clear the fault using the static bypass line. I hope everyone can understand that. Then from there, we have the next important thing. I'm going to draw the next important thing. On top of that, we have another line as well in Panapa, which is all mechanical. It's called the mechanical bypass, right? The mechanical bypass or the maintenance bypass. Anyone can say, oh, wraparound bypass, some may call it, but this is normally internal to the UPS, right? It's internal, but it's just a normal breaker to owner. Most of the time, for most UPS brands, it's not internal, it's actually external. They will have to wire it externally, but for especially the American ones, it's wired external. But for all the European brands, now Chinese brands, we can say, they just it's like the same. It's all internal, right? You have to switch it. So it serves the purpose, like for maintenance purposes, right? But here is my favorite statement, right? You take if you are asked to explain how the switching happens, because that's the question that regularly comes. Was unoda kuti ube from your UPS or switcher, do you switch bypass maintenance bypass kuti vanhu vazovhura mushini wavo clean, which is the next part where we are talking about UPS maintenance and it. What will happen here, I try and explain it in a language story. Mutora mushona, wotora mundevele, and it part two. Skapa to them shona, to them they can't understand each other, right? In the area, the maintenance bypass, mushona and the whatever, and they can't understand each other. They will definitely fight. So what happens if Akasangana, they can't communicate, they can't hear each other? So that happens here if your UPS is running online and you just switch on this guy, right? Those guys don't speak the same language, right? It will blow up. So what do they need? They need a mediator, someone who can speak both languages, right? Someone who is good in Shona and good in Ndebele. That's the static bypass for you. And this guy can speak maintenance bypass and can also speak this. So it's synchronized to the output, even though it's also connected directly to the maintenance bypass, right? So this guy can speak both languages. So you have to first, if you are running online, that means you're feeding your load here via here. You first convert that, tell the UPS, please go to static bypass, right? It means you're calling the mediator. Hey, I want to talk to my Ndebele friend here, but hey, we will fight. So please, dibatsire you. So that's when the static bypass comes in, and okay, it first checks those parameters I just mentioned, that frequencies, right? Mainly frequency and voltage. Then if it's all right, it takes the load on his own. So you can only tell, you cannot switch on this one by mechanically, the static bypass. You can only tell the machine to do it for you. You end up and it. Static bypass, that's the only time you can switch on your maintenance bypass. Right. Yeah. The reverse is true as well. When you are on maintenance, when you are on maintenance bypass, right? When you are running on maintenance bypass, right? And you want to bring back the UPS to online, this is called the online mode, where you are running straight rectifier, everything like I explained first. You want to switch on the UPS. You need first to figure out whatever UPS brand, whatever, even if it's made China, whatever, you need this guy to come in first. So you need to figure out a way to switch on the static bypass first, because the static bypass is the only guy that can speak to the UPS. So I've just explained to you something that would take probably a year for most to understand. And I just did it in 5 minutes. So I try to simplify as easy as possible. Because I've delivered this to many people before, and I believe this is the best way you can explain to anyone who doesn't even know a UPS from day one. So it's in layman's language, you need someone in the middle who can speak both languages to talk to either side. So when your contractor shows up to site, the reason why I'm telling you this is because when your contractor shows up to site, right, and you as a we call them babysitters, data center engineers and stuff, they're babysitters. Their job is just to switch the equipment to make it safe for other people to come in using a document they call the SOP. So this is what you're going to do. You're going to explain this process. So it just show off if you understand it via the language story, then it's easy for you to understand as well when you're trying to explain. But you meet a lot of engineers that will blow up missions even up to now because they can't follow this. And I know most of you guys now who remember this easier. Yeah, so from there, we're going for UPS maintenance. So UPS maintenance, there are critical parts in the UPS, right? Like we mentioned, there is capacitors, right? These are DC capacitors here. And tambotaura pipe filtration, you need to have first quick tanga kuno, because it's a filtration yekupedzisira as well. So those are capacitors that they use, right? And those capacitors, so those capacitors are depending on type or manufacturer, because you have to always refer to the manufacturer in maintenance, because that one, I guarantee you're going to ask those questions and you need to know that stuff. Depending on, you have to follow manufacturer, you go download whatever. Nowadays it's easy, you can find it online. You go and download the information about the manufacturer and you see. But for generally DC capacitors, they are replaced every 5 to 8 years. Those are the DC capacitors. AC capacitors, depending on manufacturer, some of them now are up to 10 years, right? So the AC capacitors, no more only on the inverter filter or the rectifier. This is the rectifier filter side, which is the input filters, and the output filters. The AC capacitors, those are all AC capacitors. And the DC capacitors, no more on the DC bus. And it's very easy if you remember how I explained this this process. So that's maintenance. So it's 5 years, 5 to 10 years for DC capacitors. Depending on manufacturer, you have to download the information or ask the manufacturer for the information. So no, you need 5 to 10 years to do this. You need 5 years, or it can also vary. That's one very important thing. It can also vary with the industry that you're operating in. For example, IT equipment like we are in now, it's going to last forever, very long time, right? We only replace it just for resilience purpose most of the time, so that our system won't fail anytime. Show proof that we have resilience, we are servicing our equipment, we are doing everything right possible to keep our system up to date, right? And reliability as well. That's the reason why they do it. But take, for example, a motor. For those, my electricians, a lot of electricians. If you're running a motor, the motor always kicks back, right? When the motor stops, it's firing back the voltage back into the system. So that's why you see, in my short career or long career, I've met people that try to put a elevator, connect an elevator with the UPS, and some of the elevators are very big, right? And in other countries, it's actually a recommendation. You have to put power backup. So most people will try to, no, we want to put a UPS. But no. A UPS will always suffer. Yes, there are types of UPSs that I'm going to mention, those that are capable of running motor loads, but already your motor is working, your UPS is working over time. So that UPS won't last those 5 years that we're talking about. Because when it becomes a generator, when the motor becomes a generator, it feeds back. Because remember, we're going to see when we go later that a motor and a generator is just the reverse of each other as well, just like an inverter and rectifier, just the reverse of each other. So it feeds back the voltage back into your capacitor bank. So these capacitors won't last, and these ones are the first to fail because they are connected directly to your motor. They are the first to fail. So this you're going to meet a lot. That's where most of the argument comes in. But that's the reason why I just wanted to give you the reason why motors, different types of loads can also affect the duration of or the life of capacitors, right? Then that other thing is the fans. There are cooling fans, of course. So there are a lot of cooling fans depending on type and airflow of the system. Panama cooling fans are connected. Also, most of them must be connected. They must be replaced every 5 years because their speed vary with the load. Indeed, and a lot they 10% in English manual show and you 50%. It ramps up 100%. You can't even hear each other. That's how those fans are designed. So depending on the speed is on the load as well, you need to replace your fans every 10 years. So the reason why I'm giving you that information is because you guys, whoever is going to learn those jobs, those are the questions that you're asked, and those are the things that you're going to have to know. You see. Then just general maintenance of UPS. All you need to do is switch it to maintenance bypass. How? This process is how I tell it, command it. That means there's a command section in any UPS where you tell the UPS what to do. That's the command mean. I want you to go to static bypass, so it will go to static bypass. No matter it's a Chinese UPS, it's a whatever, they all have the command section, right? Where you command the UPS to go to static bypass, then you switch on your maintenance bypass. That means then you isolate everything, then everything is dead inside the UPS. It's only one small part, which you can also cover or isolate. So it's also most of the time is barricaded, can't even reach it. So it's safe to work inside the UPS, right? When you are done, switching back the UPS, it's different from UPS to UPS, but you need to find a way, even through the manual, to bring back startup first static bypass. Then that's the only time your UPS can come back online and switch on, because you try to from there to there, kaboom. From there to there, kaboom. So you need the guy who speaks both languages here in the center. That's the static bypass. So basically, for the UPS, I'll explain the main fundamentals about the UPS. So my connection may switch off anytime, but I'm going to try and cover the next part as fast as I can after we reconnect again. But right now, if anyone asks you about the UPS now, you can say 90% of the things that are asked about the UPS, because they're basically around that. We're going to talk about the efficiency in UPSs, right? There's no 100% efficiency in UPS, unfortunately. They start from around 97, right? From 97, those are the best ones. Yeah, some may lie to tell you you're 98, but it's almost untrue. Why? Because you have a lot of losses. One is heat. All these components, when they are working here, when the booster and rectifier here, it's not just one. There's components there that are going through these heat losses. So if you ask the question, can you ever get 100% efficiency on a UPS? You must say, nah, not possible, right? Because there's a lot of losses that happens here. And again, we mentioned cooling fans, right? Cooling fans are now power to run. So that's lost power. You cannot get back, right? No matter the time. But what's fun is, okay, we're going to start with this efficiency topic after we stop, we start again. So maybe I can stay a minute. What's funny is a UPS or a generator. Efficiency is best when it's running more than 50%, when it has more than 50% load connected to it. So got 100 kVA UPS do 100 kVA generator do. And it Reno save amagets or Reno save Reno run at full efficiency. Only can tap at least from 50 kVA going up. I think from 50 kVA up, 75% efficiency. But another 25 go 50% efficiency. So the more we get closer to the full load, 100%, that's when by China